Hello everyone and welcome to this video. Today we want to talk about some past paper questions from topic 5 IB, which is thermochemistry. Okay, let us start our discussion. What energy changes occur when chemical bonds are formed and broken? We know that bond breaking is an endothermic process and bond formation is an exothermic process. When you want to break a bond, you have to give energy, and when bonds are formed, they release energy. So according to this concept, we can say that energy is released when bonds are formed and absorbed when they are broken. Because they release energy, this is called exothermic. When they absorb energy from the surrounding, this is called what? Endothermic process. The temperature of 2 gram sample of aluminium increases from 25 to 30 degrees centigrade. How many joules of heat energy were added? With specific heat is joules, gram inverse, Kelvin inverse. Now here you have to be a little bit careful here. According to the unit of specific heat, you try to convert your other units also. Sometimes they may also give you like joule, kilogram inverse, Kelvin inverse. So then we have to convert the mass. Here we already have mass, which is 2 gram, and delta T, if you will convert it into Kelvin, it will still be what? It will be 5K, because you will add 273 here, 273 here, difference will still be the same. And specific heat is given, which is 0.90. Okay, and you want to find what? You want to find Q, the amount of heat. The formula of Q is what? Q is equals to MC delta T. M is 2, specific heat is 0.9 times 5. The answer we have is 9. So our answer is 9. Using this formula, which is like Q is equals to MC delta T, we can calculate the amount of heat. Using the equation below, what is the delta H in kilojoule for the following reaction? In this case, this is our main equation. I used to call it like main equation or the main equation summary, and this is the steps, reaction mechanism. So based on these two equations, we want to design this equation. How can we do it? Let's check. Here if you see, carbon dioxide is at the product side, and in our main equation we also need it in the product side. Okay, and it's also 1, it's also 1, so we can copy the same equation. C plus O2 will give us CO2. We did nothing, neither we added anything, neither we subtracted or multiplied, divided or flipped it, so no change. So heat is also the same, minus 390. Okay, in the other side, here we have Mn plus O2 is giving us MnO2. But if you look here, MnO2 is at the product side, and here in our main equation, this MnO2 is on the reactant side. So what we have to do here, we need to flip the equation so that it also comes on the reactant side. When we flip it, what will happen? The equation will be MnO2 will give us what? Mn plus O2. When you flipped it, what will happen to the enthalpy? Enthalpy will also change sign, it will become 520 positive. Now let's solve these two equations. You see here, this O2 cancels with this O2. What's left for us? If we have MnO2 plus C will give us Mn plus CO2. This equation, when you will get this one and this one, it should be same. If it is same, it means you have done it correctly. So what we do with the enthalpy, just add these two values. When you will add these two values, what will be the answer? Answer is 130, so the correct answer will be B, 130. This is the summary. Quickly we have done this topic in thermochemistry is known as Hess law. In another video we will solve some more questions on Hess law specifically. Which statements about exothermic reactions are correct? Now we have to pick like out of these three statements which are correct. In this type of questions, always first you should read all the statements, because you may read one statement and say it is correct and choose it as a correct one, but maybe others are also correct. Okay, they have negative delta H values. This is true. Why? Because in case of exothermic reactions, product have less enthalpy than the reactants, so delta H is negative. Okay, it's because product minus the reactant, so product is less, so it will be answer will always be negative for exothermic reactions. The products have lower enthalpy than the reactants. Yes, this is also correct because they lose energy, so they have less enthalpy. And the products are more energetically stable than the reactants. Yes, that is also true because they lose energy and they become more stable. So what's the correct answer? The correct answer is D. 1, 2 and 3, all of these statements are correct. Now, a sample of metal is heated. Which of the following are needed to calculate the heat absorbed by the sample? You are heating a sample and you want to see which of these are needed so that you can calculate the heat. You remember the formula of heat we just used is mc delta T. So mass, yes, you need mass, so yes, you need this one, this is true. The density is not mentioned here. You don't need density to calculate the heat. The specific heat, yes, you need it. So what's the correct answer? 1 and 3. The average bond enthalpies of O single bond O and O double bond O are given. What is the enthalpy change in kilojoules for the following reaction? We have a reaction, and with the help of bond enthalpies, we have to calculate the overall heat. So let us see how we can do it. The formula normally used in this case is what? Sigma bond energy for bonds broken minus sigma bond energies bonds formed. We know that in a chemical reaction, bonds are broken probably on the reactant side and bonds are formed, so we call them the product side because that is what we get. So if we look at how many bonds we have here, one oxygen-oxygen bond and two OH bonds, right? So we have one oxygen-oxygen bond plus two OH bonds. Like this is one oxygen-oxygen bond and this is one and two OH bonds. These are the bonds which are broken. Now let us come to the product side. Use a if you want to be extra careful, use brackets because negative sign can create issue. What are the product side? You see here we have 1 and 2 OH bonds. So we have 2 OH bonds, and here if one molecule is having one bond, half will have half, so we can say it will have half O double bond. When you open the bracket, you will have what? One single bond O plus 2 OH bonds minus sign change 2 OH bonds and minus half O double bond O. This is plus and this is minus, so cancel. So what is left? 1 O bond, O single bond O. What is the enthalpy of single bond O? It is 146 minus what is the enthalpy here? 496. Half of 496, like 496 over 2. Okay, when we solve this equation, what answer we will get? We will get negative 102 output. So what's the answer? A minus 102 is the correct answer. Using this formula, we can solve this type of questions. Bond broken minus the bonds formed. When the solid barium hydroxide and NH4HCnR mixed, the solution is produced and the temperature drops. Okay, the main important thing here is temperature drops. Why it is important? Because we are dealing with thermochemistry and we are dealing with heat, so temperature is dropped. Which statement is correct? Equation is given to us. We want to see which statement is correct. Now temperature drops, it means what? That the system is taking heat from the surrounding. It is taking heat. System takes heat. When system takes heat from the surrounding, this reaction is known as what? This is endothermic. Okay, so surrounding will become cool, because if a reaction is exothermic, then it gives out heat, like burning of wood. When wood is burning, if you're sitting around it, you will feel heat coming out because it's an exothermic. But if it's an endothermic reaction, the system will absorb heat. So which one is correct here? This is endothermic, okay, and delta H is negative. No, this is false. Why? Because in endothermic, delta H is positive, because products have more enthalpy than the reactants. The reaction is endothermic and the delta H is positive. Yes, this is true. So the correct answer is B. Again, we have a question of Hess law. Like we have some reaction mechanism and we have the main equation, we want to derive this equation, this main equation, with the help of these reactions. Okay, let us see how we can do it. Here if you see, we have a CuO and two CuO, but here if you look here in the first equation, we have a CuO but it's on the product side. So what I will do, we will flip the equation and also multiply it with 2. Why? Because I need 2 CuO. Here I have a CuO, so I flip the equation also and times it by 2. So what I will get, this equation becomes 2 CuO will give us what? This is 1, so it becomes also 2 Cu, and half will become what? O2. Doing this, what will happen to the enthalpy? Enthalpy will change sign because of flipping and also be double. Like it is negative 156, first it will become 156 positive because of the flipping of equation, then we have to times it by 2 also because we have timed all of this equation by 2. So it becomes what? It will be, if I am not wrong, it will be around 312. Then the next equation, if you see, we have a Cu2 here and we have a Cu2 also on the product side, it's 1 1 also, so no need to do anything with this equation. Let's write it all together. 2 Cu plus half O2 will give us what? It give us Cu2O. We have nothing, not done anything with the enthalpy, so this value is the same. Let's see, can we get the main equation from this? Any cancellation? If you see, this is 1O2, like here it is in the product side and here it is on the reactant side. So it's mean you are using 1 and you are getting half. So you need half extra is there produced, right? So you can cut this 2, but on the product side you have to write half O2 because it's left. Here you have 1 on the product side, half on the reactant side. So half cancels with half. So 1 minus half is half on the product side. Any other cancellation? No. So let's rewrite the equation. Now this also cancels. 2 Cu cancel with 2 Cu. So what is left? 2 CuO will give us what? Cu2O plus half O2. See, we are getting the same equation. Now adding these two values, this one with this one, we will get what answer? In this case, our answer will be 142. So the correct answer is E. Okay. Which of the following quantities in the enthalpy level diagram are affected by the use of catalyst? When we use catalyst, what catalyst does? Catalyst lower the activation energy by giving ability to more molecules to take part in the chemical reaction. So this is EA, it will come down. When this value comes on down, more this graph will come down also. Now what will happen? More molecules can take part in the chemical reaction. So this value will be affected, also this value will be affected. This value will be the same. So the answer is what? 1 and 2. Consider the following equation. What delta H is needed? Again, this question is from Hess law. See, many questions are from Hess law. Hess law is a very important article here. So using these two equations, again we want to derive this main equation. So here we have MgO. This MgO is on the reactant side, but here it is on the product side. So what we have to do? We have to flip this equation. When we flip it, it becomes what? MgO will give us Mg plus half O2. We flipped it, so what will happen to the enthalpy? Enthalpy will also become positive. Here we did not times it by 2. Why? Because it's also 1 here and it also is 1 here, so no need to times it. Next thing, if you see, we have H2 plus half O2 is giving us H2O here, and we need nothing specifically. H2 is on the product side, we also need it on the product side, so no need to flip it. Let's see what we will get. H2 plus half O2 will give us what? H2. We have not done anything with the equation, so it comes same, right? It comes the same. Let's see if we can get the main equation. We have half O2, half O2, half O2 cancels. Now what's left? We have MgO this one. Then this is also a reactant, so here we have H2, and here we get what, Mg plus H2. Yes, this in this equation is the same, so we have done it correctly. When we'll add them, what do we get? Like 2 minus 2 is 0, 10 minus 4 will become 6, 5 minus 2 360. So our answer is what, 360. This is the correct answer in this case. Which of the following is the sign of the enthalpy chain different from the other three? Like we want to examine these four cases and we want to see which one has like different sign. Okay, CaCO3 decomposes to CaO and CO2. This reaction is basically endothermic, because to decompose this calcium carbonate you have to give heat. So this is an endothermic reaction. The sign will be what? The sign will be positive. Sodium is giving out electron. So this is what? This is basically ionization energy process. Okay, this is ionization energy, and to remove the electron we have discussed in chapter 3 that you have to give energy to the system. So this is also an endothermic process, so the sign is positive. Solid is converted to gas. You know the energy chart, gases have the highest energy, then the liquids, then the solids. Like you have ice, for example, you want to convert it into water, liquid water, you give heat. And then you have water, you want to get gas, you give further heat. So here you have solid, you want to convert it into gas, you have to give heat. So this is also a endothermic process, so sign is also positive here. But here in the fourth one, if you look, this is chlorine atoms becoming chlorine molecule. So like chlorines are joining, bond formation is there, and we know that bond formation is what? It's a exothermic process. So this one will be exo, the sign will be negative. So the correct answer in this case is D. Separate solution of HCl and H2SO4 of same concentration and same volume were completely neutralized by NaOH. X joule and Y joule are the heat evolved respectively. Which statement is correct? So let's see which statement is correct. For this equation, it's better if you write the equations first. Like you have HCl, it reacts with NaOH. Acid and base, when they react, you will get what? You get a salt and water. If you have the journal equation, it becomes very easy to write. This equation is also balanced. If you look at for the H2SO4 plus NaOH, and now you know that this is also an acid, this is also a base, you have salt and water. If you have issues in writing like what formula will come here, it's simple. You know the metal ion will come from the base, non-metal ion will come from the acid part. SO4 ion is what? SO4 2 negative, and sodium is what? Na plus. This comes here, this comes here, the formula becomes what? Na2SO4 plus H2O. So you are getting salt and water. But if you see here, its equation is not balanced, because here we have two sodiums, here we have one sodium. To balance it, we have to put a 2 here and we have to put a 2 here. According to the statement, it says that X kilojoule for HCl. So we put here an X, this is the heat value, and Y for this process, Y. Now the acids have same volume and same concentration. So if you want to compare it, you see, if you want to equalize the base here, it is 1, here it is 2. So how can you say when it to make it equal, it means Y is double. Here there are 2 moles of the base, 1 mole of the base here in case of HCl. To equate it, if I want to make it equal the heats, what I should write? I should say Y equals to what? 2x. Why I should say it like this? Because it is 1 mole using, here it is 2 moles using for the base. So it has Y, it has X. To equate it according to the answers, which one will be the most suitable one? Y is equals to 2x, because here, because of this equation balancing, we have 1:2. Okay, don't choose this one, X equals to 2Y. It means you are already Y is more. If you choose the third option, then Y will become more. We want to equate it, so we have to say Y equals to 2x. Which statements are correct for an endothermic reaction? Now we want to see for endothermic reaction. Endothermic reactions is like those reactions which take heat. So the products have more heat, so their delta H is always positive. Sorry. This system absorbs heat. Yes, this is true because it takes heat. The enthalpy is positive. Yes, this is also true. The bond enthalpy total for the reactant is greater than for the products. No, this is false. Why? Because they absorb heat, so products have more heat. So when you sum it, products will always be more. So the correct answer is what? 1 and 2. The mass of a substance M, mass is M, specific heat is C, and the increased by T degree centigrade, the temperature is T in degree. When it is delta T in centigrade is equal to Kelvin, because when you have delta T, it's already like converted, so its value is always the same, so you can use it in Kelvin also. So what is the correct answer? You know the formula. It is what? MC delta T Q formula, and here MCT, because delta T is C, so the correct answer is A. The average bond enthalpy of CH bond is 2412 kilojoules per mole. Which process has the enthalpy change closest to this value? Okay, this is a good question. For this, let us compare or check the structure of CH4. CH4 is one carbon connected with four carbon hydrogen. Sorry. So if we write it, how many bonds are there? We have four carbon hydrogen bonds, right? We have four carbon hydrogen bond. According to the statement, it says which of the four will have the closest answer to CH, this value, one CH only. If you look at the first one, the formula we discussed before was what? Bonds broken minus bonds formed, the same sigma, the energies, right? So here bond broken is how much? 4CH. This is alone, this is hydrogen. So what is the answer? Like here we have two hydrogens, so 2H. Okay, here we have what? 4CH. This is same, first and second is looks the same, only the solid and gas form different. Hydrogen, hydrogen. This is CH4, no bond here, so it will be like 4CH. But if you look at the fourth one, it is what? 4CH minus 3CH. Why 3CH? Because this is CH3 alkyl radical, it is CH3. How many bonds are there? 3 carbon hydrogen bonds. So if I minus them, 4 minus 3 is how much? 1CH. So you see the answer is similar to what is asked here. So what's the correct answer? D is the correct answer in this case. Okay. The following equation shows the formation of magnesium oxide from magnesium metal. Okay, we have an equation. The delta H is given. It's negative. It's an exothermic process. Okay, which statement is correct for the reaction? 1204 kilojoules of energy are released for every mole of magnesium reacted. The total here you see 1204. It's released. That is true that the energy is released. But if you look here, here we have 2 moles of magnesium. Here it says for every mole of magnesium. So there is a contradiction. So this option is wrong. Okay, because it says for every mole. But in the equation you can see it is for 2 moles of magnesium, not for 1 mole. So it's wrong. 602 kilojoules of energy are absorbed. It is absorbed. Here you can stop it. This is also wrong. Why? Because it's an exothermic process. The sign is telling me it's exo, so it cannot be absorbed. So it's wrong. 602 kilojoules of energy are released for every mole of oxygen gas reacted. Here you see oxygen is 1. So for 1 mole of oxygen, how much energy is released? 1204. So this is also wrong. So 1204 kilojoules of energy are released for every 2 moles of magnesium oxide formed. Here we say, look at the equation, 2 moles are formed. This is true. So the correct answer is D. D is the correct answer here. Okay. The following equation shows the oxidation of carbon and carbon monoxide to carbon dioxide. We want to give the enthalpy. It's again the question is from Hess law. Let's do it. This is our main equation, and we want to derive this equation with the help of these two equations. Okay. we have C plus O2 CO2, and here we have CO plus half O2 and CO. But here if you see, we have carbon monoxide in the product side. So what we do, we flip the second equation. C plus O2 is giving us CO2. Okay, we have to flip this equation. Why? Because we need CO on the product side. If we don't have the CO on the product side, then we will not get the answer. So we have not done anything with this equation, so we can write negative x as it is. We flip it, the second equation, it becomes what? CO2 will give us CO plus half O2. We flipped it, so it become y. It was negative, so it became positive now. Okay, let's cancel. If anything is cancelling, this cancels with this, and we are left here. It is 1 O2, here it is half O2. So how much left here? Half O2. On which side? On the reactant side, because on the reactant side it was 1, and on the product side it was half. So half left. So we have here C plus half O2, this C and this half O2, and it is giving us what? CO. So we are getting our equation. So what is the heat now? Y minus x. So the correct answer is C, which is y minus x. Okay. A simple calorimeter was used to determine the enthalpy of combustion of ethanol. The experimental value was negative 920 kilojoule per mole. The data booklet value is how much? Negative 137 kilojoule per mole. Which of the following best explains the difference between the two values? Incomplete combustion of the fuel. Nothing mentioned here about incomplete combustion, and it will have no effect on the enthalpy. Heat lost to the surroundings. Yes, this is a possible option, that heat is lost to the surroundings. Poor ventilation in the laboratory, not mentioned anything regarding this, so we can't assume it. Inaccurate temperature measurements, there is no error measurement or error being told in the question, so the best suitable answer is heat lost to the surroundings. Okay, for the reaction of this water equation, the bond enthalpies are given. We want to calculate which one is correct. For this, I think it's better if you draw the structures. H2 is what? Hydrogen bonded with hydrogen. For oxygen, we know oxygen is double bonded with oxygen. Why? It has 6 electrons, so share 2 to become stable. H2O is how we draw H2O. We have 2 hydrogens bonded separately with oxygens. So we know the equation, we discussed it before. It's what? Bonds broken minus the bonds formed. So these are the bonds which are broken. These will be the one which are broken, and these two OH bonds are the one which are formed. So let's see. 2 hydrogen. In one hydrogen there is one bond. In 2 will be how much? 2. 2 hydrogen bonds plus O2 has one bond, so O double bond with O. These are the bonds which are broken minus the bonds which are formed. In one H2O there are 2 OH bonds, so in 2 H2O how many will be there? 2 OH bonds. Now put the values. For hydrogen the value is x, so 2x plus y, the value of O double bond O, minus 2OH, so it is Z. So 1 has 2, so here it should be 4, so it is minus 4Z. So what's the correct answer we have? Our correct answer will be 2x plus y minus 4z, which is C. Which statement about enthalpies is correct? Bond enthalpy has a positive value for strong bonds and negative values for weak bonds. No, it's not correct. It has positive values for endothermic reactions and negative value for exothermic reactions, so false. Bond enthalpy values are greater for ionic bonds and than for covalent bonds. No, bond enthalpies are normally for covalent bonds. This is also not true. Bond breaking is endothermic and bond formation is exothermic. Yes, this is true. This is true, because bond breaking is endo. If you want to break a bond, you have to give heat, and if you want to make a bond, it gives out heat, so it's exothermic. The carbon-carbon bond enthalpy values are same in ethane and ethene. No, it's different, because in ethane they have single bond and ethene they have double bond, so the values are different. This is also wrong. Okay, let's move forward. An equation for the reaction in which hydrogen is formed. Okay, we have the equation. Delta H is given. Which energy change occurs when 1 mole of hydrogen is formed in the reaction? Very easy. It is see 3 moles. For 3 moles of hydrogen, we have 210 kilojoules of energy. Positive. For 1 mole, how much it will be? You divide it by 3. So this is how much? 70 kilojoule. Now this is which sign? It is positive sign. So it will be what? This will be absorbed. Why? Because it is endothermic process. Positive sign is for endothermic. So let's see which one is correct. 70 kilojoules of energy are absorbed from the surrounding. Yes, this is true. This is true. 70 kilojoules of energy are released. Endothermic process, energy is not released. False. 210 kilojoule of energy are absorbed from surrounding. For 1 mole, it is false. If it was for 3 moles, it was correct. But it is 1 mole, so it is wrong. It's again released, so this is also wrong. So the correct answer is A. The equation and enthalpy changes for two reactions used in the manufacture of sulfuric acid are, these are the two equations. We have S plus O2 will give us SO2, and these two equations we have. Now with the help of Hess law, we want to design this equation. Let's see. We have S plus 3O2. Here we have S, here we have O2. So S is needed here. But if you see, this is 1S and here we need 2S. So what is better? That we times this equation by 2. So 2S plus 2O2 will give us what? 2SO2. It will give us 2SO2. And what will happen to the enthalpy? It will be doubled. It will be negative 600. Now here we need SO3, 2SO3. Here we also have a 2SO3. So no need to flip it. Just rewrite the equation. 2SO2 plus O2 will give us 2SO3. Let's say if we can cancel anything here. This SO2 is on the reactant side, this is on the product side, cancel. Very careful, these two are both on the reactant side now. This is also reactant, this is also reactant. Now you cannot cut them, you add them. You can only cut them if one was reactant and one was the product. So the correct answer is 3O2. So it is 2S plus 3O2. It is giving us what? 2SO3. We didn't do anything. It was negative 200. So the same energy comes. So what's the correct answer? Minus 800. 600 plus 200 will make it 800. Okay. Approximate values for the average bond enthalpies of three substances are given. What is the enthalpy change in kilojoule for the reaction? Again, it's bonds broken minus bonds formed. So how many bonds are there in HF? One bond. So it is 2HF. So we have 2HF. So 2 times 565 because the value is 565 minus H2. One in H2 we have how many bonds? Only one. So we can say it's 1 here also. So it is 430 the value. And in F2 again fluorine bonded with fluorine is single bond and it's also 1 here. So plus 155. When you solve this equation you will get the answer 545. So the correct answer is A, 545. Okay, we have another question which is again Hess law. Important article, lot of questions are from Hess law. So let's see if we can do it. We have P4 plus 3O2, the two steps, and this is our main equation. In the main equation, if we see P4O6 is on the product side. In the reactant side, but here it is on the product side. So what we have to do? We have to flip it. When we flip it, it becomes what? P4O6 gives us P4 plus 3O2. And what will happen to the enthalpy? It become positive. Enthalpy will become positive. Now, what we do for the next one? We need P4O10 on the product side and we also have it on the product side. So no need to flip it. It's also 1, it's also 1. No need to times it with anything. P4 plus 5O2 will give us what? P4O10. We didn't do anything, so we kept it same. Now let's see if there is any cancellation here. This is P4 that cancels with P4. This is 5O2, this is 3O2. This is product, this is reactant. So they can cancel, but how much will be left? 2O2. 2O2 left on the reactant side. And what else we have? P4O6 plus 2O2, it will give us what? P4O10. We are getting our main equation. So what's the answer here? Our answer is negative 1400 when we add these two. So the correct answer here is C. Okay, we have a question here which is based on endothermic reaction, like which statement is correct for endothermic reactions. The products are more stable than the reactants and the delta H is positive. This is true that delta H is positive, but this is not true because they absorb energy from the surroundings, so the products are energetically not stable than the reactants. Reactants are more stable. Okay, the products are less stable than the reactants and delta H is negative. Now here this is true, but this is false. The reactants are more stable than the products, this is true, and delta H is positive, this is also true. So this is the correct answer. Here let's take this. Delta H is less stable and the reactants are less stable, delta H is negative, this is also wrong. So the correct answer is C. Which statement is correct about the reaction below? We have an equation, delta H value is given. How to solve such questions? First look at the equation carefully. Delta H sign is very important. Sign is negative. Negative value is telling you that this is a exothermic process. Exothermic process means energy will be released. Okay, if it's endo, it's absorbed, and also the sign is positive because reactants becomes products. Delta H is what? Delta H is product minus the reactant. If this value is bigger, it's always the answer is positive. If this value is less, the answer will always be negative. So the equation is given. Let's read the answers. 196 kilojoule of energy are released for every mole of SO2 reacted. This is false. Why? Yes, this is true that 196 is released. This part is true, but this is not for every mole. Why? Because in the equation we can say it is 2 moles. So if it was written here 2 moles, then it was correct, but it's wrong. So 196 are absorbed. Absorbed cannot be wrong because it's negative. It's always released. 98 kilojoule of energy are released for every mole of SO2 reacted. This is true. Why? Energy is released. This is true for every mole of SO. For 2 moles it is 196. For 2 moles it is 196. Surely if you divide it here you will see it is 98. So it's released also. This is true. This is also false because it's not absorbed. Which statements are correct for all exothermic reactions? Now we want to see which one is correct for all exothermic reactions. The enthalpy of the product is less. Yes, it is true. Why it is true? Because product energy is given out, so that it is always less. The sign is negative. Yes, for the exothermic process, delta H sign is negative. The reaction is rapid at all room temperatures. Reaction is rapid at room temperature. No, this is not true. Reaction is not like rapid at room temperature. It has also other conditions. So the correct answer is 1 and 2 here. Consider the specific heat of the following metals. Which metal will show the greatest temperature increase if 50 joules of heat is applied to 0.01 kilogram sample of each metal at same initial temperature? Okay, we have here some metals and their specific heat values are given. To understand this question, what we should focus on, what is specific heat? Specific heat capacity. Specific heat capacity is basically the amount of heat you need to change the temperature of anything, like 1 degree centigrade temperature of a substance. How much? 1 gram. Like if you have, for example, 1 gram of water at 25 degrees centigrade, you want to add heat. how much heat you should have that this 1 gram of heat becomes water becomes 26 degrees centigrade, like the change in temperature by 1 degree centigrade. So if you compare these questions, here the values are given 385, 234, 130, 134. If you look at this value, this is the lowest heat needed. Okay, like the minimum heat needed is by AU and the maximum heat is needed by is copper, Cu. So what's the correct answer we have here? It is Cu. It needs the least amount of heat to be converted according to the given scenario. Consider the following reaction. Again, this question is from Hess law. Okay, let us try this. This is our main equation, and with the help of these equations we want to design this one. Let us say this is S plus O2 is giving you SO3. Okay, SO2 plus half O2 is giving you again SO3. Now we want to flip one of them. If I flip this one, it will be okay, but still my product here still will be a reactant here. So what is better? I flip the second equation so that these can cancel also. Let's write the first equation in the same way. Nothing done, so the same value will come negative 395. But this one I should flip. Why? Because I need this SO2 on the product side. I need it on the product side. So I flip it. SO3, it will be giving me SO2 plus half O2. I flipped it, so it will become what? Positive 98. Now if we cancel, if anything can cancel here, this SO3 cancels with this SO3. This is 1.5, this is half. So when you will solve it, it will be left how much? 1. Because here it is on the reactant side and here it is on the product side. So 1.5 minus half, it will be 1. And what is left here? SO2. This cancels, SO2 is left. So the correct answer in this case is what? When you solve them, you will see it is negative 297. Okay, next question. Which statement is correct for an endothermic reaction? Okay, we have an endothermic reaction. We just discussed endo, delta H is positive and energy is absorbed. So now let's see the statements. Bonds in the products are stronger than the bonds in the reactants. No, not true. Why? Because they have more energy, they are absorbing heat, so they become less stable. Okay, bonds in the reactants are stronger than the bonds in the products. Yes, this is true, because they have less energy as compared to the product, so they are more stable. The enthalpy of the product is less than that of reactants. False. Why? Because they absorb heat, so their enthalpy is higher. The reaction is spontaneous at low temperatures but become non-spontaneous at high temperatures. No, this is also not true. So the correct answer is what? Bond in the products are, so reactants are stronger. Okay, according to the enthalpy level diagram below, which sign of delta H and what is the use reference term here? If you look at the diagram, here you see this is H, heat, and this is reaction progress. You can say time here. You see here the reactants have more heat as compared to the products. Like the delta H will be what? Delta H value is normally product minus the reactants. Here you see products have low value, so the delta H is surely going to be negative. Delta H is negative. So sorry about that, it is negative. So what should be correct here? Delta H positive, this is wrong. Delta H positive, this is wrong. Now this reaction is what? This is an exothermic process. Why? Because products have lower enthalpy. So what is the correct answer? B, negative and exothermic. When 40 joules of heat are added to a sample of solid H2O at negative 16 degrees centigrade, the temperature increases like negative 8. What is the mass of the solid H2O sample? Here 40 joules of heat. So the Q value is how much? 40 joules added to a sample of H2O, negative 16 degree. The temperature increases to negative 8 degree. Okay, like if you are like getting confused with the negative sign, to avoid it you can just convert it to Kelvin also, like negative 16 plus 273.15. So the negative part will go away. It will be 257.15. It will not make any difference, but still you can do it. Negative 8 plus 273.15, it will be around 265. So when you 0.15, you minus them, 265.15 minus 257.15, it is how much? 8K. Even if you do it in centigrade, it will be what? Same, but there is some mistake, negative sign will be there. The temperature increases, na? So 8K, it's better to do it like this. Now what Q is there? C is 2.0, and what else we have here? Mass we want to find. So we have the formula Q equals to MC delta T. M is the missing term, so M equals to Q over C delta T. Put the values, 40 divided by 2 times 8. So the answer you will get will be 2.5 grams. Okay, values are given. Again, this is Hess law. See, too many questions are in the past papers from Hess law. These all are past paper questions which are the part of IB exams. So here we have NO2 on the product side. Here we have it on the reactant side. So what we should do? We should flip this equation. Not only flip it, here we have 2 NO2 and here you have 1 NO2. So we should also times it by 2. So we get what? Flipping it and timing it by 2, we get 2 NO2. This is half, so it becomes 1. Here we have 1 O2, so it becomes what? 2 O2. And the value, flipped it, make it positive, 57 positive, and it will be what? 57 times 2, like double. Okay. Now on the next side, we want N2O4 on the product side. Here it is also on the product side, 1, 1. So no need to do anything with this. N2 plus 2O2 will give us what? N2O4. Nothing we did, so we just write it 9 kilojoule. Now let's see if anything is cancelling here. N2 cancels with N2, 2O2 cancels with 2O2, and we get what? 2NO2 gives us N2O4. So we are getting the main equation. Solving these two, we will get the answer. That will be how much? 123. Okay. How much energy in joules is required to increase the temperature of 2 gram of aluminium from 25 to 30 degrees centigrade? Again, this question simply you can do with Q is equals to MC delta T. Values are given to you. The answer should be 9. I think this is the repetitive question. We have done this before also. Which combination is correct for a chemical reaction that absorbed heat from the surrounding? Now it's absorbing heat from the surrounding. It's absorbing, so it's what reaction? It's endothermic. The delta H sign will be what? Positive. Reactants will be more stable than the products. Stable because they have less energy. So what is true in this case? Absorbing heat, so delta H is positive and it's a endothermic process. Okay, we have last question. It's also Hess law. Hess law is very important. Lot of questions in the past paper are from Hess law. It's a very important article also. I will make one more video separately on Hess law questions and the bond enthalpy questions, which are the examples in the Oxford book. So you can also check that. Let's see this one. Carbon plus oxygen is giving us CO2. Here we need CO2. It's on the product side. We also need it in the product side. So nothing, no need to do anything with this equation. We have not done anything, so negative 394 as it is. Here we have Mn plus O2 becomes MnO2. We need it on the reactant side, so we flip it. MnO2 will give us what? Mn plus O2. We flipped it, so it became what? 520. Let's see if anything cancels. Reactant, product cancels. We get what? MnO2 plus C. It gives us what? Mn plus CO2. We get the main equation which we have here, and this is the same. So when we solve it, we get the difference of 126. So the correct answer is what? 126. 26. Okay guys, these were some questions which we tried to solve. I hope they helped you somehow. So thank you so much for your time, and I hope you have learned something. Thank you guys.